All right. So retrieval utilities are you can call them as sub strategies or sub models which helps the major or main retrieval strategies to improve their performances. So we have already discussed some of the important retrieval strategies in previous classes, like vector space and probabilistic strategies. So we have seen how they work and how they retrieve the documents using their own way, in their own way. Now these retrieval utilities are the we can call them as a sub strategies or sub models, which helps the major retrieval strategies to improve their performance or to get more accurate or more relevant documents. So these retrieval utility simply enhances the performances of the major information retrieval strategies. So let's see what are the different retrieval utilities available, and let's discuss each one. Okay, first of all, let's see some of the important points which are related to retrieval utilities. Utilities improves the results of a retrieval strategy. Most utilities add or remove terms from the initial query in an attempt to refine the query. You know that our aim is to find the relevance between the query and the document. So this has been our goal since the class one. Understand? So we are trying to learn many strategies uh, which collects the relevance documents by using a queries. So um, in order we know that in some cases some strategies may perform well, in some cases some strategies may not perform that much. So these utility strategies, what they do is, they if we add these utility strategies to the main utility retrieval strategies, so what they do is they improve the performances of that model. So basically, um, ultimately we'll get the more relevant document, or what we are actually looking for. So you can see in the first point here, utilities improves the results of a retrieval strategy. Okay, and most utilities add or remove terms from the initial query in an attempt to refine the query. So how they do this means, basically they refine the query, means they may make some changes to the query so that a proper document or a relevant document is retrieved. So this is how they do it. Okay, other simply refine the focus of the query. Okay, instead of how they do it is means, instead of looking for the whole document, so they will look for the subsections of the document, so that um, they can retrieve or they can refine the query. So basically what these retrieval utilities do is they work on the queries. They try to what we say repair, you can call them as repair the queries, so that the relevant document is retrieved. So that is the main focus of these utilities. So one thing is, they may add some terms to the query, or they may remove some terms to the query, or they may limit the focus of the query to a particular section of the document. So they may not look for the whole document, they may look for a particular section of the document, so that or more relevant terms are retrieved, and those terms can be used to refine the query. So this is the approach of this utility strategies or utility models, retrieval models. Okay, the key is that each of these utilities are plug and play utilities that operate with any arbitrary retrieval strategy. So um, it's like adding some extra powers to the existing strategy. So if we use this utility strategies, so we are we are nothing but we are adding some extra power to the existing strategy so that it can perform very well. It's like a plug and play. So if you want to refine or if you want to get a quality output, then you can add that utility strategies to the main strategy. If you don't want, or if you can remove that from that strategy, or you can use the main strategy itself. Okay, now let's see what are the relevant or what retrieval utilities which are available right now. So you can see here relevance, feedback, clustering, ngram, and thesauri. These are the four important utility strategies or utility models which are there, which can be used to retrieve the relevant documents or help in retrieving the um, relevant documents. So in this class, we will discuss about this the first strategy, which is the relevance feedback strategy or model. Let's see how it works and how it helps the main retrieval strategies in retrieving the data. I hope you are able to understand what I am trying to say. Okay, so these are the small softwares which helps the major software in performing well, or it enhances the performance of the major software. Okay, now let's move on to the first utility model, which is the relevance feedback model. Let's see the points which are related to relevance feedback model. The basic premise is to implement a retrieval in multiple phases. The user refines the query in each pass based on results of previous queries. Now let's see what happens in relevance feedback. So you know this process. The process starts with a query. Based on the query, documents, one or more documents are retrieved. So in that documents, there may be some relevant documents, there may be non-relevant documents. Okay, so in this relevance feedback model, what happens is the acquiring of the documents happens in multiple phases, or the retrieval of the documents happens in multiple phases. That means you are asking questions more than one time. Generally what happens is you write query one time and you get the documents. But here what we are doing is initially we will ask a query and we will get some documents, and based on the inputs of the documents or feedback from the documents, we will again refine the query, the initial query. That means we make some changes to the query and we ask the question again. That means we write the query again. So based on the feedback we got from the first pass or first phase of the query, we write the second phase of the query, second query. So that what we are doing is, for each and every pass we are getting the feedback from the documents. That means, okay, based on that feedback we are refining the query. After refining the query we are asking the questions. That means we are again writing the query. So this happens multiple times until you get the proper document, or until your query is properly refined or properly structured. So this is what happens in relevance feedback model. Initially you ask a query, and for that query you will get some documents, and based on the feedback from the documents you refine the query, and again you write the query. Okay, so let's go in detail into this process. Okay, the third point is the user indicates which of the documents presented in response to the initial query are relevant, and new terms are added to the query based on this selection. Existing terms in the query can be reweighted used on the user feedback. Okay, let me explain this. So first user writes the query, and he will get some documents relating to that query. And what user does is user will select the documents which are relevant and which are not relevant. So this is done by the user. This is called the manual method. And based on the relevant documents, what user does is he picks the terms in the relevant documents and he adds those terms to the query. Understand? That means he is changing the query and he is picking the terms from the documents which are retrieved, relevant documents which are retrieved when a query is asked. So this process continues in multiple phases. Okay. An alternative is to avoid asking the user anything at all and to simply assume that top ranked documents are relevant. So this is another process. See, when the documents are retrieved, suppose I have asked a query and I got 10 documents as the result of that query. In that 10 documents, 5 are relevant. That means the documents which I am looking, and 5 are irrelevant. That means I don't need that documents. So what the user does is he picks some terms in the relevant documents, the terms which are which whose frequency is more. That means which are which have appeared are more. So those terms are picked and they are added to the query. This can be done in manual way so that the 10 documents are listed by the user. This is called the manual process. Or simply you can pick the top 5 or top 10 documents. So by assuming that the top 10 documents are relevant, so this process is called as automatic process. So there is no user intervention in this. Simply we are assuming that the top 10 documents which have listed are relevant. So this is what we see in Google search. So we will type a word and we will see the top relevant documents in the first page. Understand? So we assume the Google assumes that the top 10 the first page links are the relevant links to the query, and the irrelevant one or the documents with the with the lesser relevance will be in the page 2, page 3, page 4, and so on. So ranking this or deciding whether the document is relevant or not is done in two ways. One is manual way and other is automatic way. Manual way is done by the user. So user decides which documents are relevant and which are not relevant. And automatic way is simply assuming the top 5 documents are relevant or top 10 documents are relevant. So this is another process of deciding which document is relevant and not. So after the user or after we have the relevant documents, the next process is to pick the terms which has more frequency. That means which have appeared more, or the which has more weight. So each you know the weight given to the term, right? So which have more weight. So simply add those terms to the query. And when you add those terms to the query, what you are doing, you are modifying the query. And again in the second, and again you are asking using the modified query to get the relevant documents. So using either manual or automatic feedback, the initial query is modified and the new query is re-executed. So either in manual way or the automatic way, we will get the feedback. Understand? And based on the feedback, what we are doing is we are modifying the initial query and again we are re-executing that query. So after re-executing that query, we may get more relevant documents than in the first case, isn't it? Because now our query is more refined or more structured. So based on the first or compared to the first phase, the second phase results may be more accurate, isn't it? So based on the second phase results, we may again modify the query. And after modifying the query, we may we may re-execute that query in the third phase. So when you do that, then there is a chance that you may get the more relevant documents. So this process is done until the user is satisfied that he got his document, or until a certain number of steps. So this is how relevance feedback works. To keep it simple, what happens here is, in relevance feedback, initially a query is asked, and based on the query, documents are listed. In those documents, relevant documents, the documents are categorized into two: relevant and irrelevant. From the relevant documents, the terms with more frequency and more weight are selected, and those are added to the query, and that modified query is re-executed in the second phase, and you get some more documents relating to that query, and you select the frequency, more frequency and more weight terms, and you again modify the query. So this is the overall process of relevance feedback. Okay, this diagram illustrates us the process of this relevance feedback process. Initially we are asking a query, and for this query we got a result. These are the documents we got, and from this result we are designing a new query. That means we are getting a new query based on this result, and again we are executing that query and we get another result, and we modify the query again and we get the new result set of documents. So this continues until the user is satisfied with the result. Now let's take one example, so that the concept is will to help you understand the concept well. We'll consider one simple example here. The example is the let's see this query. The query is find information. So I am searching for the document um, uh, associated with the assassination of John F. Kennedy, who was the president of America. So I am looking for the documents which are related or which are associated with his assassination. So what I am doing is I am typing this sentence. This is the query. So I'm typing this whole statement here: the find information surrounding the various conspiracy theories about the assassination of John F. Kennedy. So this is the query, initial query I am asking. Understand? And in this query, you can see there are some terms which are which have more weight, or which are simply a noise, or which are not useful. Words like assassination and John F. Kennedy, these two are the terms which are which I think have more weight in getting the relevant document. So the most useful keywords are probably assassination and John F. Kennedy. So this query has many terms like find, about, the, surrounding, various, assassination, John F. Kennedy. So among these words, the only words which I found useful are assassination and John F. Kennedy, because you can find surrounding information, the, about, these words in any document. Okay, you can find. So if I use this document, if I use this term about to find the conspiracy documents of John F. Kennedy, so I may not get it, right? So I give less priority to this word and more priority to the word assassination and John F. Kennedy. So these two may get me the relevant document. So I choose them as the useful terms, and the terms like find, information, surrounding, about, various, theories. So these are as the um, noise words. Noise words means which are not at all useful for my retrieval query. Okay, the idea is to use all the terms in the initial query and ask the user if the top ranked documents are relevant. So we ask we write this query and we get some documents, isn't it? And the user selects the documents which are relevant. So let's go in the user perspective. So user selects the documents which are relevant, and he simply filters the irrelevant documents. That means he ignores the irrelevant documents. So let's see now what happens next. Assume a highly ranked document contains the term Oswald. So after the user has decided that these are the documents which are relevant, so in that relevant document, top document, number one document has a word Oswald, OSWALD. So let us suppose that document number one, the most relevant document, has this word Oswald. So what we will do is we will add this word to the query. Okay, so it is reasonable to expect that adding the term Oswald to the initial query would improve both the precision and recall. So what we will do is, since the top document has this word, so we assume that using this word in the query may get as more relevant document. So we will add this word to the query. So initially there was no word Oswald in this query. You can see here. So what we will do is we'll add this word to this query. So after removing all the noise, I'm left with assassination and John F. Kennedy words, and I also add the word Oswald. Understand? And again I re-execute that query. So I may get another set of documents. Okay. And in that documents, if a top ranked document that is deemed relevant by the user contains many occurrences of the term assassination, the weight used in the initial query for this term should be increased. So one more thing is here, if the document which are selected by the user has the term assassination many times, so in all the documents the word assassination has appeared many times. So what we will do is we will increase the weight of the word assassination here. So you can see two things here. If there is no word in the query, we are adding that word simply to the query. So which we have done in the Oswald case. So we have added this word to the query. If the word if the word is already there in the query, what we are doing, we are adding some more weight to the query. Suppose the initial weight of this query is 3. Let's assume that it's the weight is 3. Since the word assassination is occurred more frequently in the relevant documents, we will increase the weight of this assassination to 4 or 5, so that the importance of this word will increase. So what we are doing here, we are refining the query. That means we are making changes to the query so that the query is well structured and the query acquires more relevant document, or the exact document which we are looking for. So this is relevance feedback model. Got it? So first the query is asked and only the relevant only the terms which has more weight is selected. Okay, and the noise is deleted. Okay, these are simply ignored, and after executing this one we will get some documents, and in the top document if we find any word, we add that word to the query, new query, the existing query, and we also see for the words which are already there in the query. If we found that words, we will simply increase the weight of the query like we did in assassination word, so that we are increasing the importance or the weight of this word assassination. So after doing that, we will re-execute that query, and we hope that the document which we are looking for is retrieved. Understand? So this is relevance feedback model. Simple, isn't it? Okay, so we can use this relevance feedback model with the major strategies like vector space model and probabilistic model. Tomorrow's class, we will see this relevance feedback model and vector space model combined concept. So we will implement, or we will use this relevance feedback model. Okay, and we will try to um, combine it with the vector space model, and we will try to retrieve a document. Okay, so we'll see the combination of vector space model which is a major strategy, and this relevance feedback model. And we will see how they retrieve the relevant documents in the next class.